Hi, team. Thanks for showing up for your learning once again. Last question to talk about. We're just going to chat about it. This is question number 4. If we know that this quadrilateral has vertices here, we want to prove that it's either a square, a rhombus, a rectangle, or a parallelogram. What would we have to do? Okay. If this was a square, all right, then what would it look like? Well, if it were a square, it would look like this. It would have corners where the distance between sides is the same. So these would be the points, and these would all be the same. When I join these, they would all be the same length. So how would I prove that? I would use my distance formula, or I would show that they have the same rise and run. Okay, so you can use your distance formula to say, do they have the same length or not? And that either proves, is it a square or a rectangle or something like that. If it's a square, the sides have to meet at 90 degrees. And so that's a function of their slopes. So to do that, you would find the slope of this line and find the slope of that line. And if you could say that, like, we'll call this line A and this line B, all right? And if the slope of A were equal to, let's say that looks like, I don't know, 2/3. And you found the slope of B was equal to -3/2, then these are negative reciprocals of one another. Those are perpendicular lines. That would indeed be what's required to make a square. So if you can show that the sides are all the same length and they meet at 90-degree angles, then that's a square. If they don't meet at 90-degree angles, but the sides are all the same length, then that has to be a rhombus. Okay? There's no other way to have the same side length on 4 sides and not be a rhombus. Okay, a rhombus is like a flattened square where all of these are the same side length, and this angle A would equal that angle A, and this angle B would equal that angle B, but they wouldn't all be. It's a terrible sketch, but they would not be 90 degrees. This is a rhombus. This would be a square if they meet at 90 degrees. Then, how would you prove it was a rectangle? Well, if it's a rectangle, the same thing about slopes would be true. You would have to find what's the slope of these lines and prove that they're perpendicular. And you would need to show this one is the same length as that one, and this one is the same length as that one. That's a rectangle. Parallelogram is a different idea. Parallelogram is like a squished rectangle. Okay. Imagine that you had a Kit Kat bar in your pocket, and it kind of went like that when you heated it up with your body temperature, and it kind of got all squishy like that. That's a parallelogram. The same thing is true about the length of sides with a parallelogram. This has the same slope as that. This has the same slope as that because they're parallel, but they do not meet at a right angle. They would meet at, this would be some angle C, this would be the same angle C, this would be some angle B, this would be some angle B. These angles would be the same, these angles would be the same. You don't need to know what they are. You just need to tell me that this side is the same length as that and they happen to be parallel. This is the same length as that and they are also parallel. So you'd use your distance formula to show me that the sides are the same length, but that and that the slopes are the same for parallel lines. And that's how you would prove that it was a parallelogram. So I hope that's enough to get you started on that question. And happy hunting. Any questions? Absolutely find me in class or send me an email. Bye for now.